Tech Nebulous. I don't know why I did that, other than I just saw your name pop up in chat, and for some reason it amused me more than normal. Okay. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, good morning, everybody. I haven't seen Mitchell in chat, and the TTS interface is not loading. It is saying site can't be reached, might be temporarily down. Error DNS, no matching supported ALPN. Mitchell, you are here. Okay, so in the meantime, good morning to everybody. Happy barbecue day. Because so much stuff has been moved around in the factory since the last barbecue, it meant a little bit more preparation than usual, a little bit more moving heavy things around. So yesterday I spent basically the entire day, the whole day that I was not at striking class, I was here moving things. And then a bit more of it this morning because stuff was in a mess. So, sorry, I'm just periodically attempting reload in case Mitchell has figured out what was going on with the text to chat. So, in the meantime, good morning to Stephen W., Crispian Meow, yes. And you're bringing your mum to the barbecue. That's really cool. It's so many years since I've seen her. Good morning, Mitch the kitten. Amanda, making coffee and will be ready. Some call it fun. Also, Amanda said, where is it? I'm just scrolling down the chat. Ordered my 3D space mouse today. Will arrive in 10 days. That's cool. Have you tried using one? Because 3D mice are one of those things that for some people, they work amazingly well, and for some people they just don't at all. And it's something to do with the way your brain processes geometry, like spatial relationships, and whether you can map what you're seeing on the screen to the movement of the 3D mouse. Try refresh now, says Mitchell. Okay, reload. So, and the thing is that 3D mice are expensive. So if you buy one, it's loading now. Thank you. Let me get into this. Yeah, if you buy one and you can't make it work. Right, sorry. That and that, it is loading. Okay, I'll just give it a minute to do its catch up on all of the chat. There it goes. It's starting to load the chat now and catch up, and then it'll build the list. So give it a minute.
All at Fun said, here we go. Peter Lawler said, soon.
Yeah, TTS is catching up. And so I was really lucky that... Is my camera out of focus? It's probably better that way. Yeah, cool. Oh, Keith. Keith will be there. I'm here now, we'll be there later. Excellent. Mr. Barbecue himself. Without Keith, we would not have these barbecues. So, yeah, I was very lucky that Simon, my client for the water truck company, had one. He bought one, tried it, because he does a lot of CAD work, and didn't like it at all. Like, he tried it, put it in a drawer, and couldn't use it. So when I was talking about getting one, he said, try mine. And I tried it out, did the tutorial. Hang on. Where's the mute? And the yes, so he let me take his and play with it, And for me, it worked really well. It's, yes. Sorry, morning from the town of the Great Race, Andrew. All right, hang on. Let's get back to this. So, good morning to Keith, Mitchell, Crispian, some call it fun, Amanda. I know some of these are names that I've already mentioned, but I am just ticking off the list. Peter Lawler, what are you up to today? Stephen W, Mitch, David Howes, Emmy, are you coming? I guess you're coming to the barbecue today as well. Tech Nebulous, Gerald 42, Russell Rainey, Cable Tie, you're not on your bike up the mountain. Johan, Andrew Brown, Jax Tech, John Whips, Ecognito 3, yeah. Ecognito says, I'm similar with 60% keyboards, just find I can't or don't want to adapt. Yep. Ah, cool. Amanda said, yes, I've tried a 3D mouse in a shop and I will adapt very quickly. Excellent. Yeah, I find them really, really good. Don't move my bracket keys and such. Yeah, sorry, that was Ecognito talking about 60% keyboards. Yes, I have a strange relationship with keyboards I won't get into right now.
Peter Lawler said, please accept my apologies for not attending your barbie.
Okay, just this time. As long as you come to all of the others, Peter. Yeah, Ecognito.
Peter Lawler said, please accept my apologies for not attending your barbie.
Yeah, Ecognito said Dvorak or Dvorak. I'm gonna pronounce it Dvorak just because that's what most people do. So yes, I use Dvorak, and what I find. Oh, Stephen. Good morning. Delayed due to doggy walk before the barbecue and live stream. You could bring your doggy to the barbecue. You can't bring your doggy to the live stream, but you could bring your doggy to the barbecue. That would be cool. I suspect that that Andy will be bringing Falcor the Luck Dragon today. There should be at least one other dog. Yeah, so what I find is that keys that I do not use really commonly, okay, I use a Dvorak layout, but without the keycaps changed. It's with a regular QWERTY keycap arrangement. And what I find is that if I just sit
Peter
there and
Lawler
type...
said, DB OK.
Yeah, that didn't pronounce it very well at all. And if I just sit there and type, like if I'm typing regular text, not coding, but just regular text, I can type very quickly and I don't even think about it. But if you say to me, find the letter P on the keyboard, I'll go, I don't know. I think, hang on, I've got to close my eyes and go, P. Because I can't see them on the keyboard. It's just like muscle memory of where they are. And what that means is that in coding, so when you're writing English text, it's basically a string of letters with minimal punctuation. Coding is very punctuation heavy and using square brackets and curly brackets or braces and regular braces and colons and semicolons and all of those sorts of things, and dashes and underscores. So for the common things that are used a lot in coding, I can just type them without even thinking. But every now and then there'll be some character that I need to type, and I'll have to stop and figure out, where is that on the keyboard? I can't find it. But that's just the way it is. Keyboard Audio Model 100s, says Ecognito. Okay. Yeah, I haven't looked at Keyboard Audio or Keyboard IO, however you pronounce it, stuff for a while. Keyboard Audio Model 100.
Mitchell R. said, self-inflicted emotional damage.
Yeah. Cell phone. Keyboard Audio Model 100. Yes, that is very pretty. Such a butterfly. Maple, cherry, or walnut. Oh, which one is which? Which one? Okay. Low profile Mac keyboard. Yeah. Okay. Moo peeps, says Sion. Sion has arrived and hopefully will be coming to the barbecue today as well. All right. What else? So where are we? Just scrolling back. Oh yes, just to wrap up the 3D mouse thing. What I found was that when I first plugged in the 3D mouse and tried to use it, it just felt like it was crazy random stuff. Like I would try to move it and whatever was on the screen would move in a crazy hang on. Is this going to say Sion's comment? We shall see. So
Unexpected Maker
Yes.
said, "No, I am leaving, not arriving. I will arrive after I've left."
I'm glad you'll arrive after you've left. Just twist space-time a little. Yeah, so the problem is getting the mapping in your brain between what's happening on screen and what is happening with the 3D mouse.
Peter Lawler said, "Your face is crazy random stuff."
It is. Thanks, Peter. I know you love me. So I found that it was very helpful because there are so many axes on a 3D mouse. It's not just two axes. Regular mouse is X and Y. That's it. On a 3D mouse, you've got roll, pitch, yaw, and zoom. So it's yeah, it's quite different to the regular X and Y on a normal mouse. And what I found was extremely helpful was running through the tutorial, because what happens with the 3D Connection Space Mice is they have a tutorial program that basically disables all but one axis at a time. So it basically you can't screw it up. So it just, it says move this object left and right, and then move it up and down, and rotate it and zoom it and that sort of thing. So it steps you through the movements you need to do on the mouse to achieve certain movements. And then after I'd done the tutorial, it all fell into place. And once you've used it for a little while, it becomes totally second nature, and it really feels like you are reaching out. You are just grabbing the thing on the screen, whatever the object is, and you're just rotating it or moving it closer or further away. Or sliding it sideways. So yeah, it's a really, really cool thing. Now, am I still on? I hope so. I'm getting bitrate error warnings again, as usual. Let's see if we can hang in there. What else? Okay, so for what I want to do today is, okay, backtracking. The PCBs for the, yep, cool, thanks Stephen and John. The PCBs for the air quality sensor have arrived, but yeah, so my idea had been to assemble one of those on the stream today, but there is a catch. Well, there are two catches. One is, last week, I think it was, Austin gave me the excellent advice that what I should do is make sure that I get an S3 with PS RAM. And
Peter Lawler said, "IBM Model M keyboard or GTFO."
Okay, go for the good old Model M. You can drive your Model T forward while typing on your IBM Model M. IBM Model M keyboard. New Model M. What? New? New? Is this... Oh, okay. So someone is building Model M's. Right. Yeah. Oh, Ecognito says MS Natural Ergonomic 4000. Yes. Ergo 4000 keyboard. Yeah, I have a few of these. I think I've got about 5 of them because I kept wearing them out. This was my go-to until they went out of production. And now I use a Sculpt keyboard. I know I talked about all of this stuff before. So this is the Microsoft Sculpt, and it's kind of like a modernized version of the Ergo 4000. The key action is totally different, but I quite like it. So yeah, anyway. Peter Lawler, 15 USD. 150 USD, wasn't it? Yes, 150 USD. So, where were we? Oh, Mr. DIY is here. Hello. And so, okay, so I have the ESP32 S3 Vroom mini modules, which is what this board is designed for, but I don't have the versions with PS RAM. And because it has the, I misspelt it, and Google figured it out, of course. Because we've got a display on the front, and we'll probably use LVGL for the graphics library for driving that display, having PS RAM is very useful. The S3 Vroom minis that I have do not have PS RAM, which means I need to order some, which I have not done. So I don't have any. Oh look, there's a direct comparison of the 4000 versus the Sculpt. And so, yeah, interesting. So it'll be interesting to read someone's, where is it? Pros, haven't used the mouse, cons, where's the summary? Optional extra, no. Despite my initial reservations, I'm quite satisfied. Okay. There, that's the comparison of the Ergo 4000 versus the Sculpt. Squirrel, yes, Jack's Tech is calling me out on a squirrel. Yeah, Ecognito says Sculpt has a spongy escape key and I don't like the key action, but it's probably my fallback when my 4000 dies. Yeah, yeah. As I said, I have 5 Ergo 4000s around the place. I can probably see one from here. There was one on one of the pick and place machines, and then I moved it. Anyway, where was I? I was squirrel chasing. So I can't assemble it. The other problem is, well, I could assemble it and then just test the other parts of the design without doing the LVGL stuff. So that would be quite valid. But there is another thing, which is that there is a contention between the pins required for PS RAM and the... Ecognito says, you better do a stock count on them after I've left the barbecue today. I will hide them. So The oh, I just can't hold it together today. I've got to stop looking at chat. It's breaking my mind. I think I must. What is going on with my brain? Is it that I need more caffeine as like a as DIY ADHD medication, or what? Probably. It probably is. Spatchcock barbecue squirrel?
Peter Lawler
What?
said, Spatchcock barbecue squirrel looks tasty. https://www.wildmeat.co.uk/blogs/recipes/spatchcock-bbq-squirrel.
Did it really have to read that entire URL? Hang on. Just in case, because I do not trust Peter one little bit, I am clicking on the link when you can't see it. Oh, okay. No, the link doesn't look too bad. It's just, but I'm not going to bring it up. The Wild Meat Company. It's, yeah, it was a recipe for cooking squirrel. Let's not do that. So Sion said the pin contention is only if it's using octal PS RAM. The S3 Mini with PS RAM doesn't use octal. Really? Okay. Chips modules with 2 megabyte PS RAM are quad SPI. Ones with 8 or 16 are octal. All right. Is Austin here? I haven't actually seen Austin in the chat today. Cassio is here and Gavin Jackson is here. I already said hello to Mr. DIY, but I have not seen Austin. And I do not have experience with LVGL, so I do not know if 2 megabytes of PS RAM is sufficient. Maybe it is, maybe it isn't. Oh, it would be good if I didn't have to remap all those pins, because what I was planning to do was remap SPI for... What do we use SPI for? I can't even remember. Oh, the display. That's right. Okay. So we use SPI for the display, and I was going to switch those to the same pins as Austin uses on all of his boards with SPI monitors on them, SPI displays on them, so that it would be consistent with his code. 2 megabyte PS RAM is stacks for LVGL. Excellent. Thanks, Sion. Use SPI for all the things. Yeah. I'm going to bring up, because I can't actually remember what the pin remappings were going to be. Hang on. I need to dose myself with a touch of iced coffee. There we go, applied the DIY medication. Although I have actually already had a coffee this morning. Now, I am just bringing up Fusion, and then I will have a look at some of the Testomatic stuff. Because what I want to do, okay, painting the picture, where are we? Superhouse projects. Air quality sensor here. All right, I'll move this up onto the itty bitty little monitor up there so that you can see it. What was I going to remap? I can't remember. I think the idea was to remap remap SPI over to some of these pins, and yeah, I can't remember. Anyway, I'm not going to do that right now. Maybe though, I do not need to remap anything, in which case I can just use the PCB as it is. And then all is good. Peter says, wait, you're going on topic? Yeah, maybe. Let's get out of that and go to this. I need to start it up. Testomatic 2.1. So this one is slightly modified. So 2.1, I think 2.0, yes, 2.1 is modified. This is not the actual current hardware. Electrically, it is still the same, but geometrically, not so much. What I did was move the USB connector down low. It was up here, and I'm up in that sort of region. And I moved it down here so that it would be well under the top deck and clear of the test module. And what else did I do? Oh yeah, as a result of that, that forced me to move a couple of caps and make some more space. Hello, Steve. Ooh, with the Hypnotoad eye. Ooh. So where? Okay. What I want to do is test access to the various devices that we care about for I/O. So we've already tested the USB hub. We figured out problems with that. And so part of the reason also for doing the 2.1 rev of this board is I need to fix the pins on the USB hub based on what we found last time. So the version that is here right now, like the hardware. What is this? I am on topic. What's going on? Ooh, I'll hide that for a second. So this, I need to zoom out. Zoom out the, I'll take the test module off the camera. So this version has those, it's out of focus at this distance unfortunately. So those white things you can see there, those patch wires, those bodge wires, those are to fix the USB hub enable pin and something else. So, but this one has those patches applied, so the USB hub works. But what I want to do is put that back in, chuck this over. All right, so this arrived. I haven't even opened it yet. Let's check it out. The moment it arrived, I realized I'd made a mistake, but I think it's going to be okay. What I did was forgot to order these with Enig. So they are hassle, and that's not so good for edge connectors. But yeah, for this purpose, for testing, it'll be all right. I just need to remember in future to order Enig when I'm ordering any of these test breakouts. Yeah, and what you can see here is the updated version of the footprint. You see how some of these little tabs are longer? Those are the ground connections. So that if you're sliding it in, the ground connections make contact first. And on the left here, this section of the connector is all power. And you can see the ones on the top are shorter. And on the bottom, it's ground on, all of the pins on the bottom are ground. And they are longer on this little section. So that's thinking ahead to hot plugging test modules. So ground always connects first. And there's Steve with his little clipboard checking off all of the tests to be done. Yeah, so all the signals are broken out. So my general idea, I'm going to zoom this camera out. Oh, it hurts to stand up. Which way do I go? That way. Zoom out. Moving hurts. And where is the focus? Let's get... Okay, so I'm going to plug that in and then get the focus onto it. About there. About there. And then exit focus assist. All right. Now, so we've got ourselves a breakout that exposes all of the signals from the Testomatic. And that means that we can now access all of the things that come up to this edge connector on the top of the board. And we can measure things. So we can do things like exercise the digital IOs and the analog inputs and the DACs. And we could even do I2C and SPI and stuff if we wanted to. So what I want to do today is, in fact, I'm going to, where is it? Power. Let's power this sucker up. Which way around does that connector go? Goes that way. And, oh, I need to turn on the power supply. That does make a difference. What are we going to give it? We'll give it 12 volts, 2 amps, go. All right, it's spinning its back fan as it comes to life. And it should be up and booted soonish. And in the meantime, what? I don't know. Booting. Yeah, so my plan is I want to scratch my back. Hard to reach. I want to play around in Python on the tester and see if we can access the various I/O that we need to. Ooh, here we go. Look, test runner. Ooh. Yeah, VN on. Ka-chink. On. Off. And I've got the little config thing on the side here, so I can go to a second thing, and I've got the IP address being reported and shut down, although that doesn't work. Back to the test runner. Okay. Yeah, so I've done a little bit more on the UI here. It's still a bit of a mess, but yeah. So side menu to pull up the system config screen. I want to be able to do configuration through here, configuration of the Raspberry Pi. Or we can go back to the test runner screen, which is where you would normally be. Obviously the proportions are all off and things need moving around, but that's okay. Where am I? Okay, I need to do this in Bigonify and Testomatic at tester 3, not 34 yet, not quite up to 34. And test runner. Dot yeah, it's got all sorts of stuff in there. Where is it? What is it using on this particular thing? Bash RC. Okay, vim.bash RC alias L equals ls minus L. I think that'll do it. Source.bash RC. Ah, no. Now, does it work? Yes, that's much better. Okay, now I'm more comfortable. So, you have mail. I do have mail. Stephen W. says, your USB differential pair traces are not at all run like differential pairs. That is true. That comment was probably from a little while ago. That'll be referring to this. Yes, that is true. I have two answers to that. Sorry, just switching to fusion mode here. So this trace and this trace are not the same length. Johnny! Thank you, Johnny, for that membership gift. My hot Swedish friend is here. This is going to go on for a while, isn't it? Okay, I'm turning the volume down a little bit so I can continue talking while we celebrate. Yep. Thank you for the Rickroll. Yeah, that was all right, Mitchell. Rickrolls are always welcome. So, okay, where were we? That's right, I was looking at the signal. So this signal is DP0 and DP1. Though I didn't designate them with the suffixes that allows me to use the differential pair routing thing. This is a long way of saying I don't care because differential pair routing on USB 2.0 matters far less than many people think. If you look at the clock timing on USB 2.0 and the speed of light, so the distance of the trace and how many nanoseconds it takes for skew to occur between the two signals, you need a really big difference in the length of the tracks. So yeah, a little while ago someone did this calculation and told me what it was, and it was a lot. Like in order to achieve enough skew that you have a problem, the difference in tracks has to be massive. Yeah, I can't remember the number, but it was like 10 or 20 millimeters or something. So yeah, I just haven't cared that much about differential pair USB. So I do it when I can be bothered. And in fact, I did it on, where did I do it? I can't remember. There was somewhere just in the last week that I was routing USB, and I did it as differential pairs just because it was easy. Because the tools are there, like I can just do route differential pair and have Fusion take care of it. Ooh, Johnny just signed up. As a member again, do we get a thing? We probably will. Is this just because you want to be rickrolled again? And of course, Johnny's comment was sex's rule. Yes. Tech Nebula said, remember, all PCB rules can be broken as long as you know the consequences and willing to deal with them. Yeah. I think probably, what happened then? I think probably part of the issue is, you know, where's did the UI, what? That was weird. I think part of the issue is when the effects are cumulative, because you might, for example, have a bit of a length mismatch on your traces and think, oh yeah, it's off by 5 millimeters, doesn't matter. And then you plug it into some other board, which also has a trace length mismatch of another 5 millimeters, and it happens to be on the same, in the same direction. And now all of a sudden, ooh, Sion says, okay, I'm leaving now, going to pick up some goodies and head over now so I can annoy you on stream.
Unexpected Maker said, okay, I'm leaving now, John. Going to pick up some goodies and head over now so I can annoy you on stream.
Nice. Thanks, Sion. I will see you soon. Jack Sex says, timing-wise, yes. EMI-wise, no. But realistically, it doesn't really matter until it's high speed. Yeah. Old-style USB 2.0 is... Here we go. Crispian is now a member, thanks to Peter Lawler. I hope I don't get copyright strike for this. Yeah, it's going to happen a bit, isn't it? Oh yes, I was sad to see that the never going to give you up video was pulled off YouTube. The one that has been used for so many years as the destination for Rickrolls, that URL now does not work, which is sad. Oh, Mitchell says it's out of license, so it should be fine. Okay. I thought copyright was like a lifetime of owner plus 80 years or some crazy thing. Thanks to Mickey Mouse. Mickey Mouse. Now, yeah, but okay, I am going to reroute this, I think, because one of the other things I'm going to do is I'll move this. Where was I going to move stuff? I was going to move something up here. I can't remember what. Up into that area. Oh, Don S is here. Hello from Las Vegas. Don S from New Zealand is no longer from New Zealand. Don S is now Don S from LV. What do you call Las Vegas? LV. All right. It is now nearly 45 minutes into this, and I haven't even started. I have not even started. Ooh, Johnny. Dare I click on this link? Dare I click on it? I don't know. Hang on, I'm going to mute, and then I'm going to click. Oh, Ben. Hello, Ben. I don't think I said hello to you yet. Ben said, currently have a popcorn maker pulled apart on my bench. Going to add in temperature and fan control. Ah, cool. Okay, this is just for those who were missing it. Oh, this is on the original Rick Astley channel. 1.6 billion views. Yeah. Okay. I'm going to pull that off, or I'm going to get a copyright strike for showing the video, even without the music. Loading it, rolling into it. Yeah, so what I want to do is in here, okay, I'm going to open another window. I'm just going to bring this down off here to make it more convenient for myself temporarily. I will bring it up where you can see it in a second. So I want to go into Projects, Testomatic, and let's bring this up and put it on the right, and we'll bring this and put it on the left, and clear. Should be able to just do that. Notes. Okay, here we go. So DUT power control, Fermata, config files, config parser, Thea's tester. Just make sure I don't have my password in here. These are my notes from how to set this up. Kiosk setup. Yeah, all of this is going to get added into documentation at some point. So I've got setting up the touchscreen, setting up the label printer, ESP tool. Okay, so what I want to do is yeah, so this stuff works. Pin control 17 blah. So with this we can control power to the device under test. And hang on, I've got a cough again. TTS is broken again? No, I don't think it is, Peter. Where was it? What was Peter trying to say?
Peter Lawler said, his TTS is walking again, squirrel.
No, I don't think it is. Oh, it didn't say your 1.5 billion views thingy. Oh, and it didn't say your other thing either. Okay, I don't know why. So what I want to do is do some experiments with Python, with things like talking to the devices in here. So if we come into Testomatic, not the USB thing, we want where, oh, there. What we want is okay, I want to be able to talk to the INA 260. Okay, let's make some notes and have an actual kind of plan for how to do this. Let's bring this to the foreground, that to the foreground, and to validate. Hang on, why didn't that work? There, okay. To validate, INA... Why? My keyboard is being strange. Funny after that conversation about keyboards earlier. INA 260 current sensors. And I want to validate the DACs, the ADCs. Oh, okay. So MCP 23017 IO expanders. I think that'll be one of the more straightforward ones because they are so common. Then let's check out yeah, MCP 23017s. We've got ADS 1115 and MCP 4728. So MCP 4728 DAC and what was it? ADS 1115 ADC. Is there anything else that we need to communicate with? Oh yes, I remember. There is also the flash memory. Flash memory. Oh, yeah, there's something weird going on. Man, it's not the keyboard specifically. There is something that happens in macOS sometimes where it becomes really laggy. Crispian says, you're echoing here as you're broadcasting on multiple devices and carefully synced. Yep. Yes. Stephen W. is right. That's on your side. That is a you problem, Crispian. Okay, so we've got those. We've got USB hub, which is kind of sorted. Then we've got over here hat EEPROM, Raspberry Pi header. Okay, so we've got two things. We actually have two of these EEPROMs. Cat24C32. Cat24C32 EEPROM. I'm going to mark these as separate, as different, like two different entries for this. Cat24C32 EEPROM, and that is on the test module, because they are actually on different I2C buses. And testing the hat one could
Dick in the
be...
Ghetto said, hello, everyone.
DIY. Welcome. So testing the hat one is going to be a little bit more work. All right, so these are to validate things. Do collaborations, right? Now, ADC. What am I doing? Brain fade moment. All right. These are the things that we need to check. Oops. I just did an undo. How do I do a redo in Vim? Let's ask. Let's ask Google. Vim redo. To redo the last undone change. Control R. Okay. Control R. Hang on. That was Command R. Nope. Let's write that. And I have no idea what's happened to the rendering in this. Here we go. Okay, that's better. It's back. It had a weird rendering freak out, I think because of the zoom level. That's better. Now. No, I don't need to quit. I just need to get this out of the way. One of the changes that Apple made in the latest Mac OS is they added window tiling, so snapping to window edges and that sort of thing. But it does not at all handle different monitors with different aspect ratios properly. It has all sorts of little bugs. So I normally use Magnet as a tiling manager, and I turned off Magnet because I wanted to try Apple's tiling manager, and it is no good. Not compared to Magnet anyway, so I need to disable Apple's and turn Magnet back on. Okay, so what are we doing here? We are going to see if... Okay, hang on. Where is... I'm just looking at the schematic here for something. We should be able to do voltage sensing. Let's start with the current sensors. Yes, let's do that. So, what we want is INA 260 Python. Let's see how hard this is to figure out. Adafruit Second Python. No, I just want regular Python. INA 260 driver. No, I'm going to need to do a VN or something, aren't I, before I get into this, or it's going to complain all over the place. I think it's about time that I got myself understanding VNs again. It's fallen out of my brain. Okay, built-in sense resistor, SM plus, yeah, from blah, import controller, that, blah, blah, blah. Okay, so what I will need to do is install it. INA 260 pip install. Let's try that. I bet it's going to complain because because it'll say that it is a managed, the environment is managed. Oh, hang on, maybe it's working. What? That worked. How? I don't know. But I'm not upset that it worked. I'm just surprised that it worked. So let's do this. From blah, import controller. Badoink. Okay. So we will set, what did I set as the address? Before I hit enter on this, let's have a look on here again. And address, this is all pulled low. Yeah, address 40, 41, 42 are the 3 sensors. And ooh, DIY, you have become a member. Silver supporter, thank you very much. What is this today? Looks interesting. What it is the Testomatic system, and just trying to validate that the hardware is okay and bring it up from the and bring it up from the software point of view to be able to talk to the peripherals on it. Alright, so we've done that. Let's have a look at what voltage it thinks is available. There won't be current because the output is turned off and there's nothing consuming it. 11.8. This is working. What's wrong? What? How? I don't get it. It's working. Alright, in that case. Let's do this. INA 260 current sensors. From there. Oops. And it was, I am going to stick these notes in here, and then and then I will have them next time. There we go.
Peter Lawler said, leak hacks.
What, the where, who now? Lead hacks, yeah. I'm a lead hacker because I'm copying and pasting code off a web page and it's working. So leet. I am in script kiddie mode. Playing on easy. So from blah import controller, yeah. And what we could do is say, now can I just do this and redefine that object? I can. All right. 5.05. Okay, so that's on the 5 volt rail. And now if we go to the third current sensor, we should get 3.3 volts. Print voltage, 3.30625. Nice, we have wins. Okay, so our just to bring back the schematic to recap, for context, what these things actually are is the power monitoring and control for the device under test. So what we do is we have the main V in that comes in. So this is coming off the bench power supply or whatever it is that's plugged into the that's powering the whole thing. So we've got the V in going through this INA 260, which is measuring the voltage and also the current that is flowing through. That then goes to a relay, and the relay can be controlled by the by the Raspberry Pi. So we already have in here, wherever it is it below? There, yeah. So from here, we can use these commands to fire the relays to turn on the 3 power rails, V in, 5 volts and 3.3 volts going to the device under test. And that's what these relays are for here. So now what we can do is by running this in Python, we can measure the voltage, and if I did current, it'll say 0, oops, current. Yeah, 0, because we don't actually have anything pulling power off that power rail at the moment. These power rails are dedicated to the device under test. It has a dedicated 5-volt regulator. Excuse me. And a dedicated 3.3 volt regulator. Which reminds me, I think that on the next iteration, let's add some to-dos to ourselves. What I should do is replace, so I've got this little LDO, which is currently running the 3.3 volt rail to the device under test. What I should do...
Wake up, Jeff.
Yeah. I'm doing my best, Peter. What I should do is put another LMR 38020 in there. So add another switch mode regulator in place of that linear regulator. But yeah, it works. The reason for that is just that it would give us more overhead. So this AP2112K only does up to 600 milliamps, but with the switch mode regulator, I can give it more. And also what I could do is take it directly off. So at the moment I've got these kind of daisy chained. So I've got the output from main V in goes to the 5-volt regulator, of course, because it needs to come from somewhere. And then the output of the 5-volt regulator is this 5-volt raw line, which is sensed and switched. And that goes to the input of the 3.3 volt regulator. So if there is a lot of load on the 3.3 volt rail, what that will do is draw power from the 5 volt rail as well, because that's what's feeding it. So I think what I'm going to do in a future revision, let's add to-do. Oh, there's already a to-do list there. What does it say? Add cooling fan output. Check if 10K make the breakout hot pluggable. Add cooling fan output. No, I don't actually need to do that, so I'm going to delete that. I'm going to say replace DUT3V3 regulator with LMR 38020 directly off VN. Yes, that looks like a plan to me. And let's try, I don't actually even know if this has been done. I need to check this. Fix enable on USB hub. That's it. And Stephen W says, copy the 5 volt switch mode and change the current sense resistor / inductor. Yes, exactly. That is my plan. Oh, Mitch said main power or mains power? Oh, this is in relation to something else from Capastor. Any ideas what might be a good MOSFET configuration for switching main power to certain peripheral? I used P-channel but seems fishy. Would appreciate some explanation if you know it whenever free. Okay, so Mitch asked the correct follow-up question, which was main power or mains power. Very different things. And yes, Mitch suggested following it up in Discord. So there is Stephen W said, are you going to need to do power sequencing if both 5 and 3v3 are both from the main V in? Well, the thing is, you can do that on demand anyway, because what you can do is at the start of the test, like before the board goes in, you can have all 3 of those power rails turned off because they are controlled on the output side by these relays. And then when you begin the test, it's up to you as the person designing the test to decide which of the power rails need to come up and what delays you might need between them, etc. So yeah, unless I'm misunderstanding the question, which is probably the case, I think it'll be fine. Okay. Where? Okay. So Yeah, all right. So we've shown that the INA 260s are working. This is almost too easy. And by saying that, I have cursed myself. No, not that one. I want to focus on that terminal. And I'm going to say, okay. Now, though that's probably the easiest of the things to check. Okay, to validate, let's do MCP 23017. Oh, hang on. Let's do Python scan I2C. Python code. A lot of these sorts of things are Circuit Python or MicroPython, and I want just regular Python. Okay, import subprocess blah I2C detect. Oh, okay, this is just this is calling out to the command line thing. Yeah, which is just, it's not native Python. Let's do this. Minus y1. Yeah, so we've got, oh, that's actually fewer devices than I was expecting. So we've got the INA 260s on 40, 41, 42. We have some devices on 20 and 21, but I don't know what they are. Let's see what 20 and 21 should be. That's actually kind of disappointing, because I would expect to see more devices than that. 20 and 21, where are they? Maybe they'll be these IO expanders. But we're not seeing addresses 48, 49 for the ADCs, and we're not seeing address 60 for the DAC. Ooh, maybe there are some problems with those. Yeah, Tech Nebula says port expander. Yeah, so in fact what I should do is, let's make notes of this. That'll be 20, 0 hex 20. But at least we can play around with the port expanders and validate that they are working properly. And this one will be address 21, because its address 0 line is pulled high right there. Okay, so what we can do now is maybe drive IOs on this. Okay, I'm going to search for Python MCP 23017 GPI expander library for Raspberry Pi. Okay, let's see if this will do anything useful. Set pin mode, etc., etc. Set up an object, import, blah, creates an I2C object as a wrapper. Yep. Create an MCP object with the given address. Okay. Now, let's see how we install that. Now there was that. Pip install. I'm just going to try this. MCP 23017 Python. It's highly unlikely that it will work, but it's yeah. Could not find it. Pip search MCP 23017. I don't even know if pip search works. No, does not support pip search. Okay, let's go and do it in a browser if it insists. Search, and I want to search for MCP 23017. MCP 23017 library, January 26, 2024. There are a lot of things here that don't seem to be related. It's matched on the MCP, perhaps? Okay, let's try this one. Oh, it's the same one. Okay, it is the same one that we were just looking at. So, installation. Oh, it's just MCP without the Python. Okie dokie. Let's try this. All right. And I'm going to make similar notes under here so that future me does not have to relearn all of this stuff. MCP 23017, IO expanders, do the slash, IO expanders, and the URL. Where did I have that? Let's just put this in here for now. The URL for it is that. And oops, that. And this will get us started, but then I'm going to need to look in the code to see what from that. I must have not been in insert mode. All right. Let's just get rid of that. Okay. So if we do that, we should have the MCP object, and then we should be able to do stuff with it, like turn outputs on and off. Oh, Mitch said venv fun python -m venv env and dot env bin activate. Okay, but for now, Python. I want to do. If I paste that, is it going to get the line numbers? Let's find out. It does. So, what's turning the line numbers off? I can't remember. So I'm just going to do this. Do it one thing at a time. So I did the import. Oi. Let's go back from that. Import that. Back to that. No module found I²C. Does it? Okay, so there's a dependency here. Where is the I²C thingy? How do I enable I²C? If I just search for I²C, it's going to have thousands of results. Capastor has asked a slightly strange question. Yep, I'm resisting being distracted by that. Mitch has intercepted the question. So, what was I doing? That's right, I²C. Do I need to import I²C or something first? What else? So we've got from I²C import I²C. Maybe I just need to install it. Python I2C support. Class I2C. How to write a Python? Oh, maybe we just need SMBus. Driver for the bus device. Yeah. I don't know. Okay. Who here has done this before and can give me the answer and help me cheat and jump straight to the end instead of trying to figure this out? So we're failing on from I2C import I2C. Presumably this is because in a default Python installation it does not have the I2C module installed. So I need to install it. Let's just try this. Pip install, totally guessing, it's probably going to fail. But it gives me an opportunity, yep, to have some more iced coffee. Back. All right. Capstore said you got to enable I2C from the Raspberry config, I think. Yeah, but that, you are right. Raspberry config. Yes. However, I think I've already done that, and this, I'm pretty sure, is a different problem. Enable, yes, yes, yes. Yeah, I'm pretty sure it was already enabled. The problem here is different. The problem is that Python is unable to import I2C, and that would not be dependent on the hardware. That's just a thing happening in memory, because we're not even at the point of, maybe import SMBus. Let's try that. Python. So we're not even at the point of trying to communicate on the bus. We're just trying to create the object in memory. Let's try import SMBus. So we'll see if that part fails. Oh, that worked. Okay. Now let's try this from again. Now that we've got SMBus imported. Yeah, not found. No module named I2C. How about I try the advanced script kiddie leet hacking method of Googling for the error message. Done that. Where's the answer? Where's the answer? So do I have to install Python 2? No. I don't think this is related. Okay, so one thing that is slightly confusing me here is I did this earlier and the INA260 worked without importing I2C. So actually this is a good point. This verifies that the I2C bus is working, and also the fact that I did this scan earlier and we found devices on the bus. So that was using the command line tool, not doing it in Python. Stephen says, Googling an error message is a very advanced concept. You need your issue raised to level 2 tech support before someone else can do that for you. Yep. What I could have done is lmg.fy.com. Oh, what? Yeah, I want to go to it. Why won't it let me click through to it? Connection is not private. I don't care. Just take me there. Reload. Advanced. Turn on enhanced protection. No! I want to ignore the warning and go to lmgtfy. Oh, it's going to .app. What? Why is it redirecting to .app? Why? Why did it go to .app? That, yeah. Anyway, something bad is trying to happen. This is unsafe. Jack's Tech said Chrome blocks it now as it spoofs Google. Yes, of course it does. Yeah, I can see I can see why they would be upset about that. So for those of you who have no clue what's been going on for the last 30 seconds, what I was trying to do was go to a website called Let Me Google That For You, which is a passive-aggressive thing. Hang on, let me Google that for you.com. Let's see if I can get to it in Safari. Safari can't open the page. All right, I'm going to see if it's at a different, let me Google that for you. Oh, okay. Here we go. Okay. So, this is for when people ask you a question that they could have answered themselves by searching for it. So, let's see. How do I enable I2C in Python? Google search. Oh, it's got a whole lot of merch. Done. Okay, so now we copy the URL. Copied. All right, so what happens is someone asks you a stupid question that they could have answered themselves. You come here, you search for it, you copy the URL, and then you send them that URL and say, here's the answer. And the answer, so they paste in the URL, and it says, you go here, you click in the box, you type the messages, you click search, and here's an answer. Come on, was that really so hard? And it, yes. I do not need to be your outsourced Google interface. Input command, okay, finish, reboot, yeah, done all of that, that's not a problem. Enabling and checking, blah, yeah, okay, let's just forget that for now. Where are we? Yes, so I'm sure that for people that work in tech support, 90% of what they do is sit there and listen to someone ask them a question, type it into a search engine, and then tell them the answer. Why don't you ask ChatGPT? It says, wild. Mitch said, I accidentally typed pip install 2IC. Now Python wants to make me coffee and fend off spammers. Yeah, okay, so let's try that. ChatGPT, log in. Let's, what's my OpenAI login? Here we go.
I'm not quite sure how to help you with that.
Alexa, stop.
Peter Lawler said, to use I2C in Python, try SMBUS2 module.
Ah, okay. Thank you. That is the sort of answer I was looking for. So it'll be something like SMB.
Peter Lawler said, I2C low-level stuff is wild and generally very board dependent.
Okay. So I can't do that. Let's try. Where was it? Install SMBus2. Will this do anything? Requirement already satisfied. It says it's already got SMBus2. So pip install SMBus2.
Pip install SMBUS2.
Yep. That is what I've done, and it says that it was already installed. And board dependent. Yep. All right. Now, I'm going to ask ChatGPT. Now, what am I actually going to ask? What prompt are we going to use here? I'm going to say, okay, I'm going to ask a bit of a stupid question. How do I install I2C support in Python 3? And we shall see what it says. Oh, how to enable I2C in Python. Yep. Using SMBus2. Pip install SMBus2. Yes, I've done it. Bus 1 is used. Bus equals smbus bus.write data, blah, circuit Python,
Peter
okay.
Lawler said, write my some Python SMBUS2 code to drive I2C.
Write some Python. True, yeah. Use the original smbus library. Okay, let's see if there are any more clues in this. So I've already got smbus2 installed. And so then I can do import smbus2. How far did I get back up here? I did, let's bring this back to the top of the screen. Python. Oh, maybe I just need to import oh no, this worked. Import smbus, that worked. Let's see if smbus2 works. Yes, it does. But this did not work. This is the problem thing. From I2C, module not found. All right. Oh, hang on. I've got to bring it up where you can see it. In Python 3, when I do blah, I get the error module not found error. That's not a question, but let's just see what it says. Because there isn't a module called I2C directly available to resolve this issue. Yeah, I've already got smbus2.
Mitchell R said, pip install I2C.
Yeah, I tried that. Quit. But I'll do it again. Install I2C. It just said there was no module available, I think. Yeah, no matching distribution found for I2C. All right. All of this is based on the instructions for that particular MCP library. So maybe, oh, okay. Peter Lawler has a suggestion. Let's try this. Oh, someone says try just skipping that line.
Peter Lawler said, from SMBUS to import I2C or something.
Yeah, the thing is though, that skipping that line is going to mean that these subsequent lines are not going to work, because we can't create the I2C object unless we've got... But yeah, you're right, maybe... Yeah. I could just try skipping that line. So let's do that. And then we'll do the import smbus, because that works. And then we'll try this to create the I2C object. I2C is not defined.
Mitchell R said, most people will probably use the SMBUS Python module import SMBUS. This implements SMBus, but not I2C.
Implements SMBus, but not I2C.
Mitchell R said, PigPio has a complete implementation of the SMBus and I2C commands import PigPio.
Sorry, I'm just going back through chat. Let's try this one. From SMBus2, import I2C. No. I2C. No. Denied. Ooh. Peter says, my PyCharm LLM is all over this. Okay. So I am just bringing up... Oh, come on. No. I do not...
Peter Lawler said, my PyCharm LLM is all over this he.
All right. This is what Mitchell was just linking to. PIO, PyGPIO, PigPio, I think that sounds better. There's a complete implementation, import PigPio. I know it's meant to be PyGPIO, but PigPio sounds funnier. So for Python, see that, look at that, I2C open, GPIO to access local I2C buses. Okay, so I think I am possibly going to sidestep this because I don't want to have to implement all the I2C stuff myself. That feels like way more work than I should have to be undertaking. So let's have a look for oh, Peter sent me a message. I'm a bit worried about opening a message from Peter. Ooh, it's potentially a useful thing. From SMBus2 import SMBus, I2C bus, device UX40, register, initialize the, okay.
Mitchell R said, see the comments about SMBUS on that page.
Yep. Okay, on this page. So anyway, what I'm thinking of doing is sidestepping this sub part of the problem and looking for another MCP 23017 driver, because I'd like to find something that implements the functionality in a neat way so that I can just do like a digital write or a digital read to pins. I don't want to have to write that whole driver myself and do the low-level manipulation of the registers. So most people, hang on, Mitchell said to look at something. See the comments about SMBus on that page. Okay, comments about SMBus. Hang on, I got a sneeze coming. Oh, I've got no idea where that came from. Totally without warning. Well, almost without warning. Just time to mute. ls dev I2 yeah, true. Linked here directly. Oh, okay, cool. Thanks, Mitchell. Let's click on that link and go straight to it. And
Peter Lawler said, ACHOO.
I didn't pronounce it very well. Johan said to do ls dev I2 star. Yeah, the bus will be there. I'm going to do that just to be absolutely sure. But if we do ls dev I2 star, there'll be two buses there, or one. I2C bus 1. Bus 0 is only initialized during startup, and then it is uninitialized, removed, deleted, whatever. It's used by the Raspberry Pi for accessing its HAT EEPROM. But bus 1, which is the one we care about, is definitely working because I can do I2C, where was it? What was that? Yeah, I2C detect. I2C detect, whoops, minus Y bus 1. And yeah, we can scan the bus and we can see the devices. So the bus is definitely working. That's not the problem. The problem is the driver within Python to communicate with it. lsmod grep I2C, yep. Okay, so back to the link that Mitchell sent. Combined read or write transactions, single I2C, blah. Oh, I'm going to need a little snooze after this live stream. Oh wait, I can't. I have guests coming. Yeah. Yes, but this. Okay, so Mitchell, are you saying to do something like this just to verify that we can communicate with the chip? Because I do not want to have to do this register manipulation. Yeah, in Python. Okay. So, all right. Mitchell is suggesting doing this. Let's do this. and see where things go. Python, bring this back to the top of the screen, and do this. Let's try that. And with SM bus 1 as bus, so we'll do, yeah, I'm putting this in line by line. Message equals that, so from address 0, 64 bytes, let's try it from address 20. I've got no idea how many bytes, but let's just say 64 bytes. And it didn't, oh, okay. It didn't like that. 1, 2, 3, 4. Let's see if the indentation works. Ah, thanks Python and your stupid lack of semicolons. That. 1, 2, 3, 4. Paste. That. Ah. And then that. 1, 2, 3, 4. Why can't you just use delimiters like a proper language? Oh, hang on. Here we go. Now we've got to do this again. That. And then that with address 20. And then that. And then that. Oop. That was me resting on the keyboard. Or I just want to say screw it, have Python just open a process calling the working binaries, that way you know it's 100% going to work a bit easier. Yeah. Yeah. What? Oh, Crispian says, you can sleep while we barbecue. Okay, so... oh, Peter has a comment here. Say vim
Peter
py file.
Said, Python 3.13's new interpreter command line editing tool was enough for me to forward port as much as I could.
Okay.
Mitchell R said, vim a py file. It's gonna be easier. Then
Yeah.
just call it lol.
Yeah. But your comment earlier about calling a binary, a command on, just call it as a an external process. Let's see. Raspberry Pi MCP 23017. Are there any binaries with this that support this? Because this would allow us to at least validate the testing the hardware. Yeah. Okay, we found it. Command line test. So do I2 set. First, configure I2C set. Okay, then we set that to logic high, so we can just do I2C set commands. That's interesting. So we've got, yeah, we'd need, maybe it is simple enough to write a driver for this, because we just need to do some bitwise manipulation. So we need to keep track of what the current settings are for each of the I/O pins, and then do some bitwise manipulation to change this payload. Ben says there is an SM bus 3. All right. Just a heads up, it is now 11:40, which means that it is getting to be approximately time when early people may start turning up at my doorstep. So this, as is tradition, when there is a barbecue on, this live stream may end up descending into randomness, chaos, and then just end. So we'll see. We'll see. All right, what I want to do is, can I check? Can I check? What would have been nice is if I had wired LEDs or something up to the I/O pins first. Trady says, I thought all live streams were random. Yes. Yes. Now, we could do set GPIO 0 to logic high, which will enable LED. So, why is that 14? So, that's the address of the... let's zoom this a bit, make it readable on the stream. So, we are setting that GPA 0 to 6 as outputs and GPA 7 as an input. So that, what is this second one doing? Okay, so I2C set. What we're doing is setting, oh, that must be a register, maybe? Then we set GPA 0 to logic high, which will enable the LED. Turn off the LED, we use that. So that's the, maybe register 0 is the directions, like the pin modes, and register 14 is for writing the pin values, I guess, maybe? That seems likely. Alright, so what we can do is take this. Oh yes, there is a car pulling up in the driveway. Let's take... Whoops. Test runner. Let's do this. I2C set blah. Okay. Now we are going to do... So I'm just going to cargo cult these commands for now. And stick the multimeter on them. And check... I wonder who it is. It's a white car. It's possible that it's my dad. Whoever it is parked like right in the driveway, in front of the roller door. So let's. Oh, it's Sion. It's Sion. Come on in. Hang on, got to switch back to this view.
No, I'm hiding.
No.
Oh. Anyway,
Come on in. Hey.
How are you?
Very good.
Hey, everyone.
You got to duck down. Camera's down there.
Peter Waller said, it's not me.
Yes, grab a chair. Peter, no, you're still in Tasmania, aren't you? Hiding away. So,
Hey, everyone.
how are
This
you
is
doing?
Cool. Good.
Yeah.
This is very cool.
So this is the first time Sion has been here for reference, and
It's different
we'll
in
do
real
the two.
life than
Yeah.
on
Then looking through there.
Yeah.
Yeah.
For sure. Different scale.
Yeah.
Different everything. Much messier.
Much messier.
Yeah.
And I've been cleaning for days for the barbecue.
Oh, really? It's great. It's really good.
It's perfect. Yeah.
Yeah.
Okay. So I am just messing around with I2C and trying to talk to the MCP 23017.
COLAB time.
Collab time, yeah. We should do that. Talking to the I2C IO expanders on the tester. Oh, I haven't yet, but getting there. I was trying to do it out of Python, and it was complaining about the I2C module not existing.
Okay.
I couldn't figure out how we install that. So now I'm just trying the command line tools.
Is it 4 or 5? It's just a bit different now.
That's a good question. It's a 4, I believe. Yeah. I can see the devices. Like if I do, let's just switch back to there. If I do I2C detect on bus 1, I can see the devices are there.
Yeah.
I'm just trying to communicate with them. So I've just set, address 20 is the first expander. Set everything. What have I done here? I'm just going to do this, and then I'm going to wrap up the live stream.
Have you got Blinker installed?
Blinker? No.
Install Blinker. It's Adafruit's.
Ah,
It's
okay.
their bridge that allows you to use.
Oh,
you don't
like
have to use it,
like Circuit Python. Yep.
in Python, but it basically gives you really good
Yep.
access to chips and everything else. Yeah, yeah.
Okay.
I caved. I had the same problem with my test jigs. I'm
Yep.
using 2 of those, and
Yep.
I just caved and put Blinker on.
Okay. So is it as a
Pip
package
installer.
or pip install
Pip
Blinker?
install. It's called Adafruit Blinker, I think.
Adafruit Blinker like that.
Yeah. You might have to go to their web.
Let's see what happens.
You might have to go to their website.
Oh, no, it looks like it's working. Okay.
And it basically gives you just pure Python, be able to talk to stuff.
Yeah.
Also, if it makes a mess of all your stuff, I apologise.
That's all right.
Done some research first.
No, that's all right. I've these testers. I just start with a clean Raspberry Pi OS install, and then I've got notes about how I do the setup. So starting from scratch is not a problem, and I'm treating this as like a scratch pad. I'm just doing experiments, seeing what
this
works.
won't break other things that you've got running already. So I don't know. Like
Yeah.
it puts a whole bunch of stuff on there.
Okay. Alrighty.
Like they've got, if you go to they'll have a learn guide for how
Yep.
to talk to the MCP chip, and it'll have a version for Raspberry Pi as well as for CircuitPython stuff.
Yep. Okay. Well, that is cool.
If you can be bothered.
I'm inclined to not do that now.
Yep.
I think I'm going to wrap up the live stream a little bit earlier because, yeah,
Peter Lawler said, John's face is a scratch pad.
more people are going to start arriving. Yes, Peter.
Can I take notes on your face? Can I?
Yeah, I've
Whiteboard?
got
A whiteboard?
I've got a Sharpie here somewhere. It's a red Sharpie, and then it can look like you've done it in blood.
You have too many buttons in front of you.
Yeah, I know.
Oh my.
Luckily, most of them I don't have to care about because they're scripted. Like that, I don't have to care about because it's all scripted through here.
Right, okay.
Yeah, and then companion. So one thing there runs a companion macro, which then calls into macros that are stored in the ATEM, which is pretty cool.
Not complicated at all.
No, not at all. It's just a house of cards. Okay, so I will, before I wrap this up, what I'm going to do is make a note on here to investigate Blinker.
Yeah. It just gives you like CircuitPython style access
Yeah.
to all the stuff, and all of their libraries will now work for any peripherals you've got that you plug in.
Yeah.
Now, whether it's screens or LEDs or whatever else, you can just use any of the CircuitPython
Okay,
libraries now.
that's cool.
And I'm not saying that their libraries are performant in any way,
Yeah,
but they work,
yeah,
and they're pretty reliable. So
yeah.
just easy.
And for
sometimes.
something like a test jig, it's not really a matter of super high performance. We just need something that's quick and easy to
Absolutely.
lash stuff together.
Yeah, especially dealing with things like using the internal. It doesn't have pull-ups. Does it pull-ups? Just pull-downs? Maybe both. But anyway,
Yeah, I can't
doing
remember.
that and setting I/O in and out and reading different banks and stuff. Like they've got all that code in there for you to do. You
Yeah.
Just treat it like a normal.
Nice.
So yeah.
Okay, that's good. I was wanting to avoid having to write all of that stuff myself. So if someone else has wrapped it all,
That's how I started.
much
I
better.
just couldn't get it working properly. Just
Yeah,
shit. Well,
awesome.
swore.
I've done worse. Okay. Alrighty. So, I am going to go and start getting
Peter
ready.
Lawler said, go barbecue, gents.
Yes. Thanks, Peter. We will. Sion is just going for a quick look around the factory.
Hey, you keep your floor so clean and white. Impossible.
I lick it clean. So I am going to wrap up the live stream. Oh, my dad's here as well. And for those of you who are coming to the barbecue, I will see you really soon.
Yeah, nice to
And for everybody else, I will see you next week. So thank you very much, and I will catch you later. Bye.
You do the Simone.
Yeah, the Simone Yetch. Bye.
I swear, Apple Maps sent me in circles. I must have gone
In
the
circles.
longest route to get here.
Yeah.
No way. I don't know.